Imagine a morning like any other. The sun rises exactly where it always has. Light spills across oceans and continents with familiar precision. Winds follow invisible highways in the sky. The oceans breathe in long, patient currents. Beneath your feet, the ground feels solid, dependable, eternal. And yet, everything you see is already moving. You are moving eastward at extraordinary speed, faster than a jet aircraft, carried effortlessly by the turning of the planet. You don't feel it because everything around you shares the motion, the air, the water, the mountains, the cities, even the atoms in your body. Earth spins and life spins with it. Now imagine that motion ending, not gradually, not gently, but instantly. For 10 seconds, the planet forgets how to turn. There is no warning, no cosmic announcement, no flicker in the sky. Rotation simply ceases, as if someone has placed a colossal hand on the world and held it still. 10 seconds does not sound like much. You can hold your breath for longer than that. A heartbeat lasts a fraction of that time. But on a spinning world, 10 seconds is an eternity, because motion does not disappear just because the planet does. Inertia, the ancient law written into the fabric of the universe, demands that everything in motion remains in motion unless acted upon by force. Earth may stop, but the atmosphere does not receive the message. The oceans do not pause to ask permission. You do not suddenly lose the speed you were given at birth. The moment rotation stops, the ground betrays everything resting upon it. At the equator, the surface of Earth has been racing eastward at more than 1,600 kilometers per hour. In an instant, the planet halts beneath that speed. The ground freezes, but everything above it keeps moving. The air tears itself free. Winds explode across the surface of the planet, not as storms, but as walls of force. The sky itself becomes a weapon. Atmospheric currents surge eastward at unimaginable speeds, shredding clouds into elongated scars. Pressure collapses and rebuilds violently. Sound becomes irrelevant. The wind moves faster than shockwaves can carry it. Forests are flattened as if brushed aside by an invisible hand. Buildings are peeled open, their outer layers stripped away and carried into the sky. Steel bends, concrete fractures. Anything not anchored deep into bedrock is instantly lost. Human beings, animals, vehicles, anything with mass but no protection are thrown eastward. There is no balance to regain, no time to react. The force is absolute. Bodies become projectiles. Survival in the open is impossible. Closer to the poles, the speed is lower. The violence is still extreme, but marginally less absolute. Distance from the equator becomes the difference between annihilation and improbable survival. But the air is only the beginning. The oceans rise next. Water, unlike land, does not stop suddenly. The seas surge eastward, climbing out of their basins, driven by momentum accumulated over billions of rotations. Entire bodies of water slosh toward continental edges, overtopping coastlines in a single unstoppable movement. Tsunamis form not as waves, but as moving walls of ocean. They sweep across shores with no rhythm, no retreat, only advance. Coastal cities vanish beneath churning water. Harbors cease to exist. The ocean does not flood gently, it rearranges geography. As water races eastward, the planet's shape betrays another secret. Earth is not a perfect sphere. Its spin has pulled it outward at the equator, giving it a subtle bulge. When rotation stops, gravity begins reclaiming that stolen shape. The oceans respond instantly, migrating toward the poles, sloshing, surging, redistributing their mass. Sea levels drop dramatically at the equator and rise catastrophically in higher latitudes. Entire seafloors briefly emerge while distant lands drown beneath new temporary oceans. For 10 seconds, Earth is no longer balanced, and beneath all of it, deep within the planet, something far more dangerous is stirring. The molten outer core, an ocean of liquid iron thousands of kilometers beneath the surface, does not stop spinning just because the crust does. It continues its motion, lagging behind the sudden stillness above. The interaction between core and mantle shifts violently, sending seismic energy rippling upward. Earthquakes erupt across the globe not as isolated events but as a planetary convulsion. Fault lines rupture simultaneously. Volcanoes awaken without warning. Magma surges toward the surface, driven by pressure systems never meant to exist. For 10 seconds, the planet screams. And then, just as suddenly as it stopped, Earth begins to turn again, but nothing returns to normal. The crust lurches eastward, attempting to catch up with the rotation it lost. The atmosphere, still racing ahead, now collides with the moving surface from the opposite direction. Winds reverse violently, shockwaves ripple through the sky. The oceans, already displaced, now slosh back again, generating secondary tsunamis that crash into what little remains of the coastlines. The planet does not resume rotation smoothly, it stumbles, and in that stumble, civilization collapses. Satellites fall from disrupted orbits, power grids fail everywhere at once, communication ends in a single global silence. The night sky fills with burning fragments as space infrastructure re-enters an atmosphere that no longer behaves as expected. 10 seconds have passed, but the damage will last centuries. In the aftermath, the sky is unrecognizable. Cloud systems have been shredded, scattered, reassembled in grotesque new patterns. The familiar circulation of air, the great planetary breathing that once regulated climate, has been broken. Jet streams no longer follow their old paths. Some collapse entirely. Others strengthen into permanent rivers of wind that never dissipate. Storms form in places where storms never existed, while rain vanishes from regions that once depended on it for survival. Day and night still come, but they feel wrong. Heat lingers where it should not. Cold advances where it was once kept at bay. Seasons lose their predictability. Crops fail not because of one disaster, but because the rhythm of the planet itself has been disrupted. The Coriolis effect, the force created by Earth's rotation that once guided winds and ocean currents, is now unstable. Currents wander. Warm water no longer reliably travels from equator to poles. Cold depths rise unpredictably, chilling coastlines and collapsing marine ecosystems. The oceans, already battered, begin to die. Plankton populations crash as nutrient cycles collapse. Fish migrate into unfamiliar waters or vanish entirely. Coral reefs, already fragile, bleach and crumble under thermal shock. The great underwater forests of kelp are torn apart by relentless currents that never settle. Life on land fares no better. Survivors emerge into a world stripped of familiarity. The horizon looks the same, but nothing behaves the way it used to. The sun feels harsher. The wind never truly rests. Dust storms roam continents that were once green. Ice advances in some regions while deserts bloom in others. Human civilization, built on stability and prediction, cannot survive such chaos. Cities without power become tombs. Transportation networks are useless without coordination. Knowledge survives only where people survive, and people survive only in pockets near the poles, deep underground, or in regions sheltered by geography and sheer luck. For the first time in history, humanity is no longer a planetary species. We become scattered again, but Earth does not care. The planet has endured far worse: asteroid impacts, supervolcanoes, ice ages that smothered continents, extinctions that erased nearly all life. This event is catastrophic but not fatal. Life adapts. Insects thrive where mammals fall. Microbes flourish in poisoned seas. Plants evolve new tolerances to unstable climates. Slowly, painfully, ecosystems rebuild, not as they were, but as they must be. The Earth that emerges from this moment is familiar only in outline. It still spins, it still orbits the sun, it still supports life, but it remembers the 10 seconds when everything broke. And deep in the layers of rock and ice, in the scars of coastlines and the rearranged chemistry of the air, the planet carries the evidence forever. This was not the end of the world, it was the end of the world as it once was. And as the dust settles and the winds slowly learn new paths, a larger question remains, one far more unsettling than the destruction itself. What does it mean that everything we depend on, climate, gravity, balance, time, exists only because a planet continues to spin? That question is where our journey truly begins. When the violence finally fades, it does not do so gently. There is no clear moment when the catastrophe ends and survival begins. The planet does not announce that the worst is over. Instead, the world settles into an uneasy quiet, like the aftermath of an earthquake that has not yet decided whether it is truly finished. The air still moves with unnatural force. Winds continue to race across the surface, though no longer at their initial impossible speeds. They howl through broken cities and over stripped landscapes, carrying salt, dust, ash, and fragments of what once belonged to civilization. The sky remains restless, layered with unfamiliar cloud formations stretched thin across the horizon, as if the atmosphere itself has been wounded. For those who survived the initial 10 seconds, the silence afterward is almost worse. There are no engines, no distant hum of power, no coordinated signals traveling invisibly through the air. The world has gone quiet in a way humanity has never experienced. In some regions, the ground is still warm from friction and tectonic stress. In others, frost creeps outward as displaced air masses bring sudden cold. Fires burn unchecked where lightning and ruptured infrastructure ignited forests and cities alike. Smoke columns rise into a sky that no longer disperses them efficiently, turning daylight into a dim, copper-tinted glow. The sun still rises and sets, but it feels altered, too bright, too sharp, or sometimes muted behind persistent haze. Without stable atmospheric circulation, heat lingers where it falls. Days grow hotter than memory allows, nights colder than expected. The planet has lost its ability to evenly share energy. An energy imbalance is the true legacy of those 10 seconds. Before the stoppage, Earth's rotation quietly organized everything. It guided the winds, shaped the oceans, and stabilized climate zones. Now those invisible systems are fractured. The atmosphere behaves less like a carefully tuned engine and more like a shaken container still trying to find equilibrium. Weather no longer follows patterns. Storms form without warning, not over warm seas as before, but wherever pressure gradients happen to collide. Rain falls in violent bursts, flooding dry land, then vanishes for weeks or months. Entire regions enter drought while neighboring territories drown. Agriculture collapses almost immediately. Fields planted according to centuries of seasonal knowledge fail to produce crops. Seeds sprout too early or too late. Pollinators vanish from areas where flowering cycles no longer align. Livestock, already stressed by lack of water and shelter, succumb to heat, cold, or disease. Food becomes the first great divider between survivors. Those near remaining freshwater sources gain temporary advantage. Those who depended on long supply chains find themselves helpless. Modern cities, once marvels of efficiency, reveal their greatest weakness: total dependence on systems that no longer exist. Within days, desperation spreads, but the Earth itself is still changing, still adjusting to the shock it absorbed. The oceans, having sloshed violently during the stoppage and restart, continue to oscillate. Sea levels fluctuate unpredictably as massive bodies of water seek new equilibrium. Coastlines no longer resemble maps. Some lands remain permanently submerged, while other regions expose ancient seabeds never before seen by human eyes. Ocean currents, once reliable conveyors of heat and nutrients, lose coherence. Warm water pools in stagnant regions, raising sea temperatures far beyond survivable limits for many species. Cold, nutrient-rich water wells up in unfamiliar places, triggering sudden algal blooms that choke coastal ecosystems. The great marine food web begins to unravel. Plankton die-offs reduce oxygen production. Fish populations crash or migrate chaotically. Whales and large predators strand themselves on altered coastlines or starve as prey disappears. The ocean, which once buffered Earth against extreme climate swings, becomes unpredictable and hostile. On land, the biosphere fractures along lines of adaptability. Fast reproducing organisms thrive. Insects expand into niches left vacant by larger animals. Microbial life explodes in disturbed soils and polluted waters. Fungi spread across fallen forests, digesting what remains of the old world. Larger animals fare worse. Migration routes are disrupted. Rivers no longer flow predictably, cutting off access to breeding grounds. Extreme weather events eliminate entire populations in a single season. The age of large, slow reproducing species begins to close. Humanity is forced into the same brutal selection. Those who survive do so not because of strength or intelligence alone, but because of location, preparation, and chance. Underground shelters, polar research stations, remote islands, and mountainous regions become accidental sanctuaries. Knowledge becomes fragmented, preserved in isolated pockets rather than shared globally. Language itself begins to diverge as communication ends. And yet, even as civilization collapses outwardly, something deeper is happening within the planet. The core and mantle, once synchronized with the planet's rotation, continue to adjust. Earth's magnetic field, generated by the motion of molten iron deep below, wavers. For a time it weakens, allowing increased cosmic radiation to reach the surface. The auroras become visible far from the poles, painting the skies with ghostly light even at lower latitudes. But this beauty comes with danger. Increased radiation stresses living cells, increases mutation rates, and damages what little remains of electronic infrastructure. The sky becomes both shield and threat. As weeks pass, Earth slowly regains a form of balance, not the balance it once had, but a new configuration shaped by violence. Atmospheric circulation reorganizes into unfamiliar cells. Prevailing winds establish themselves along different paths. Climate zones drift. Deserts expand where moisture no longer arrives. Rainforests shrink or fragment. New temperate regions emerge in places once considered inhospitable. This reshuffling happens faster than evolution can comfortably follow. Extinction accelerates. Species vanish not one by one, but in waves as cascading failures ripple through ecosystems. When a keystone species disappears, everything that depended on it soon follows. Forests collapse into grasslands. Grasslands erode into dust. The Earth enters a bottleneck, a narrowing of life's diversity driven not by a single impact or eruption, but by systemic instability. And yet, within that narrowing, opportunity exists. Life has always thrived on disruption. The empty spaces left behind by extinction invite new forms to emerge. Plants with greater tolerance for heat, cold, or irregular rainfall spread rapidly. Animals with flexible diets and behaviors adapt. Intelligence, social cooperation, and generalist survival strategies become more valuable than specialization. For humanity, survival becomes local and intimate. Communities shrink. Technology regresses to what can be maintained without global supply chains. Fire, water, shelter, and food once again dominate daily existence. Knowledge is passed orally where books and digital records are lost. The night sky, freed from light pollution, reveals the stars in astonishing clarity. For the first time in generations, survivors see the Milky Way stretching overhead, not as a curiosity, but as a reminder of scale. Above them, Earth continues to spin. The rotation is stable again, but its consequences are forever altered. Days remain 24 hours long, but their experience feels different. Time itself seems heavier, slower, burdened by uncertainty. Years pass. Children are born into a world where stories of global civilization sound like myths, where airplanes are legends and satellites are falling stars, where maps are unreliable and seasons are suggestions rather than rules. These children adapt. They grow up knowing how to read the sky for storms that no longer follow calendars. They learn to recognize edible plants that flourish in new climates. They understand migration not across borders, but across survival zones that shift unpredictably. Humanity does not vanish, it transforms. And as generations pass, the memory of the 10 seconds becomes distorted. Some cultures remember it as a punishment, others as a cosmic accident. Some forget it entirely, leaving only geological scars and genetic bottlenecks as silent testimony. But Earth remembers, in the layers of sediment deposited by sudden floods, in the abrupt extinction lines preserved in rock, in the altered chemistry of the oceans and air. The planet carries the evidence of the moment it stopped and started again. And far into the future, long after cities have crumbled and new ecosystems have claimed the ruins, a question will remain written into the fabric of existence. If 10 seconds could do this, what other delicate balances quietly hold the world together? That question leads us forward to the deeper forces that make a spinning planet habitable at all, and to why rotation is not merely motion, but the silent architect of life. That is where the next part begins. Long before there were cities, before forests covered continents, before life itself learned how to breathe, Earth was already spinning. Rotation was not an afterthought, it was not a feature added later. It was foundational, a consequence of chaos giving birth to order. When the young planet formed from the debris of a newborn solar system, collisions imparted momentum, and that momentum never truly left. From the very beginning, Earth learned how to turn. And in that turning, something extraordinary happened. Rotation transformed a lifeless sphere of rock into a world capable of balance. The spinning of Earth stretched time into rhythm. It created day and night not as abstract concepts, but as cycles that life could synchronize with. Without rotation, sunlight would scorch one hemisphere endlessly while the other froze in permanent darkness. With it, energy could move, disperse, soften. Rotation did not just move the planet beneath the sun. It taught Earth how to share warmth. That sharing became the foundation of habitability. As Earth spins, the atmosphere is dragged along by friction with the surface. But because the planet is round and rotating, the air does not move in straight lines. It curves, it bends, it twists. This bending, the Coriolis effect, is subtle but powerful, shaping global wind patterns that distribute heat and moisture across the globe. Trade winds carry warm air westward near the equator. Westerlies transport temperate air toward mid-latitudes. Polar easterlies confine cold air near the poles. These invisible rivers of air regulate climate with astonishing precision. When Earth stopped spinning even briefly, these systems unraveled. Now, as the planet spins once more, they are rebuilding, but not exactly as before. Rotation also governs the oceans. Water responds to the same forces as air, curving and circulating under the influence of Earth's motion. Massive gyres form in each ocean basin, transporting heat across thousands of kilometers. Warm currents like the Gulf Stream once carried tropical warmth northward, softening winters and sustaining ecosystems far from the equator. That gentle redistribution was never guaranteed. It existed only because Earth kept turning. After the stoppage, ocean circulation reorganizes into new patterns. Some currents weaken permanently, others intensify. Heat becomes trapped in some regions and scarce in others. Entire coastlines enter new climatic regimes that human memory has no reference for, and beneath both air and water, another force quietly resumes its work. Gravity. Earth's gravity is not uniform. Rotation slightly weakens gravity at the equator, where centrifugal force pushes outward. When rotation stopped, that balance was briefly lost. Gravity reclaimed the equatorial bulge, pulling mass inward, downward, poleward. Now, as the planet spins again, gravity and centrifugal force renegotiate their compromise. The shape of Earth adjusts subtly but permanently. Sea levels settle into new baselines. Continental crust shifts microscopically under redistributed loads. These changes are invisible to a single lifetime but unmistakable in geological time. The planet has been reshaped not dramatically but decisively. Life responds to this reshaping in ways both fragile and resilient. Plants begin to colonize newly exposed land where seas receded. Pioneer species take hold in unstable soils, their roots anchoring sediment and slowing erosion. Over decades and centuries, forests emerge in places once underwater, while former fertile plains degrade into salt flats and deserts. Animals follow the plants cautiously at first. New migration routes form, old instincts fail. Species that can adapt behaviorally, not just genetically, gain an advantage. Flexibility becomes survival. Human communities mirror these biological shifts. Settlements cluster where conditions stabilize. Rivers that regain predictable flow become lifelines. Knowledge of the land becomes more valuable than any artifact of lost technology. Stories replace maps. Experience replaces data. The planet is no longer something humanity controls. It is something humanity negotiates with. As centuries pass, Earth systems continue to settle. Atmospheric circulation becomes more stable, though never identical to its former state. Seasonal patterns re-emerge, but their timing drifts. Monsoons arrive earlier or later. Winters grow harsher in some regions and milder in others. The ice caps respond slowly. Polar ice retreats unevenly, reshaping coastlines and sea levels over millennia. Glaciers carve new valleys where ice once stood still. The scars of the stoppage are written into stone. Geologists of the far future will read this layer clearly. They will find an abrupt boundary, sediments deposited by massive floods, a sudden loss of biodiversity, a sharp chemical shift in ocean deposits. They will name it. They will argue about its cause. They will debate whether it was cosmic or terrestrial. They will not know how close the planet came to losing its delicate equilibrium. Deep within Earth, the core continues its relentless motion. The magnetic field stabilizes once more, though its structure is altered. Poles wander differently. Field strength varies subtly. Radiation levels normalize and life adapts to the new baseline. The auroras retreat toward the poles again, though they remain brighter than before, a lingering reminder of instability deep below. Through it all, rotation remains constant. The planet spins not because it wants to, but because the universe demands it. momentum is conserved, motion persists. And in that persistence, life finds opportunity. After enough generations, humanity begins to rebuild not globally but regionally. Cultures diverge dramatically, shaped by the environments that shelter them. Some societies grow along new coastlines, others thrive in high latitudes once considered marginal. Technology returns slowly, unevenly. Metalworking re-emerges where resources allow. Simple machines reappear. Written language spreads again. Astronomy regains importance not for navigation alone, but for understanding the rhythms of a sky that once betrayed the world. The story of the stoppage becomes legend. In some cultures, Earth paused because it was wounded, in others because it was tested. In others still, the story fades entirely, replaced by myths of great floods, endless winds, and a time when the world shook itself apart. But the consequences remain. Even thousands of years later, Earth is a reminder of how narrow the margins of habitability truly are. Rotation, gravity, distance from the sun, none of these are guaranteed. They are circumstances, not promises. And this realization changes how future humans see their world. The planet is no longer a backdrop. It is an active participant. Every sunrise is evidence of motion sustained. Every predictable season is a quiet triumph of physics over chaos. Every stable climate zone is a fragile agreement between forces that do not care whether life exists. The 10 seconds when Earth stopped spinning taught the universe's oldest lesson in the harshest way possible. Stability is not permanence, it is maintenance. And as long as Earth continues to turn, life has a chance, but turning alone is not enough. It is the balance between motion and restraint, between energy and order, that allows a world to remain alive. The idea that Earth could suddenly stop spinning feels like fiction because, in almost every meaningful way, it should be. A rotating planet carries an almost incomprehensible amount of angular momentum. That momentum is not fragile. It is not easily interrupted. It is one of the most stubborn properties in the universe, preserved across billions of years, across collisions, across catastrophes that would obliterate civilizations without leaving a trace. To stop a planet is to argue with the fundamental rules of reality. And yet, to understand how close or far such a moment lies from possibility, we must ask a dangerous question, not whether Earth would stop spinning, but what it would take to make it happen. Because the universe has never promised safety, only consistency. Earth's rotation began at birth, when the young planet coalesced from the swirling disk of gas and debris around the newborn sun. Every collision added spin. Each impact tilted, accelerated, and shaped the rotation that still defines day and night. The moon itself, formed from a colossal impact, altered Earth's spin, slowing it, stabilizing its axis, giving rise to tides that would later shepherd life from sea to land. Even then, rotation endured. Over billions of years, Earth has gradually slowed. Tidal interactions with the moon steal a tiny fraction of angular momentum, lengthening our days by milliseconds per century. Fossil corals preserve this truth in their growth rings, recording ancient years with more days than our own. The planet has never stopped, not during asteroid impacts large enough to melt crust, not during volcanic episodes that reshaped continents, not during ice ages that locked oceans into frozen silence. Rotation survived everything, so what force could possibly overwhelm it? The first candidate is impact. A sufficiently massive object striking Earth could, in theory, alter its rotation. But the scale required is staggering. An asteroid large enough to halt Earth's spin would not merely cause devastation, it would partially liquefy the planet. The energy involved would exceed that of any known extinction event by orders of magnitude. Such an impact would not pause rotation cleanly. It would shatter equilibrium entirely, leaving Earth spinning differently, tilted wildly, perhaps even torn apart. Stopping rotation is not a gentle act. The second possibility lies in gravity itself. A close encounter with a massive object, another planet, a rogue star, could exert tidal forces strong enough to torque Earth's rotation. Over time, such forces can lock a body into tidal synchronization as the moon is locked to Earth, always showing one face. But time is the key word. Tidal locking takes millions to billions of years. It is slow, patient, inevitable only when circumstances persist. There is no sudden halt, no dramatic pause. The planet gradually yields its spin, surrendering it molecule by molecule. A 10-second stop does not fit this process. Then there is the most exotic possibility, internal failure. Could Earth's own structure betray it? The planet's rotation is shared across layers. The crust, mantle, outer core, and inner core all rotate, but not perfectly in sync. Subtle differences exist. Earthquakes can momentarily alter rotation by microseconds. Large redistributions of mass, such as melting ice caps, can slightly change the length of a day. But these effects are whispers, not shouts. No known internal mechanism could abruptly arrest the motion of an entire planet without tearing it apart, which leaves us with an unsettling conclusion. If Earth were ever to stop spinning suddenly, even for 10 seconds, the cause would not be natural in any familiar sense. It would require an external force of extraordinary precision and power, one capable of applying torque evenly across an entire planetary mass, then releasing it without catastrophic fragmentation. Such a force borders on the artificial or the cosmic. This realization reframes the scenario entirely. The question is no longer simply what would happen, but what kind of universe allows it. Because a universe capable of halting a spinning planet even briefly is a universe where familiar assumptions fail, where laws still apply but are manipulated at scales far beyond human comprehension. In such a universe, Earth's 10 seconds of stillness would not be an accident, it would be an intervention. That thought alone is enough to unsettle even the most grounded imagination. But suppose, purely hypothetically, that some mechanism could do it. Suppose a force exists that can couple to a planet's rotation directly, bypassing crust, ocean, and atmosphere alike. Suppose it can pause angular momentum without shredding matter, like a hand gripping a spinning wheel without friction. In that case, the implications reach far beyond Earth. Rotation is everywhere. Stars spin, galaxies rotate, even spacetime itself twists under the influence of mass. If rotation can be halted, then motion itself is negotiable. And if motion is negotiable, then stability anywhere in the universe is conditional. This is where speculation becomes philosophy. Earth's brief stillness would not just be a disaster. It would be a revelation, a demonstration that the universe permits interruptions far deeper than storms or impacts. It would suggest that the rules we experience daily are not guarantees but tendencies. Tendencies that can be overridden. For survivors, this realization would change how reality is understood. The sky would no longer feel distant. The planet would no longer feel passive. Existence itself would feel provisional. Over time, this awareness would seep into culture, belief, and science. The idea that Earth could pause would become symbolic, a reminder that nothing is truly fixed, that even the most reliable cycles depend on forces beyond perception. Humanity, having lost its illusion of permanence, might grow humbler, or more fearful, or both. As generations pass, the event recedes into myth, but its psychological echo remains. Civilizations that rise afterward build differently. They avoid coastlines that once betrayed them. They respect climate volatility. They tell stories about balance, motion, and restraint. They understand that survival is not dominance but alignment. Earth itself continues to teach this lesson. Its rotation remains steady but not invulnerable. The moon continues to slow it imperceptibly. The sun's gravity tugs constantly. Asteroids still roam. The galaxy itself moves through space, carrying Earth along in a cosmic current that no life form can feel directly. The planet spins within spins within spins. Nothing is isolated. And in that nesting of motions, Earth's 10 seconds of stillness stand out as an anomaly, either impossible or deeply significant. Which brings us to the final and most uncomfortable possibility. What if Earth did not stop spinning because of physics, but because physics allowed it to? What if the laws of nature permit rare, extreme events that operate outside our intuitive expectations, not violations, but edge cases so unlikely that they appear impossible until they happen? The universe is vast enough to host phenomena we have not yet imagined, and Earth, despite its familiarity, is not exempt from cosmic surprise. Time after catastrophe does not heal in straight lines. It folds, it layers, it leaves echoes. Centuries after Earth's brief stillness, the planet no longer looks wounded at first glance. Forests have reclaimed ruins, coastlines have stabilized into new shapes, rivers have learned their altered paths, the air no longer howls with the same relentless violence, and the oceans have found rhythms that, while unfamiliar, are once again dependable. To a child born long after the event, the world feels whole, but the planet remembers. It remembers in ways that are subtle, persistent, and impossible to erase. In stone, there are layers of sediment laid down in a single, chaotic moment, thick bands of mixed material where ancient coastlines were drowned and reshaped. In ice cores, there are sudden spikes of ash, salt, and isotopes that speak of atmospheric upheaval. In fossils, there are gaps, entire branches of life that simply end, never to reappear. These are not mysteries to future scientists, they are signatures. Markers of a moment when the planet behaved unlike itself. As human societies rebuild and mature, curiosity inevitably returns. Survivors may have been too busy staying alive to ask deep questions, but their descendants are not. They inherit a world that works again but bears scars too precise to ignore. Why did the seas rise so suddenly in the ancient records? Why do myths from distant cultures all speak of endless winds and a sky that turned against the land? Why does the rock remember a single moment of chaos rather than a gradual change? Slowly, patiently, science is reborn, not in gleaming laboratories or global institutions, but in quiet observation. People measure shadows again, they track the sun's path. They chart the stars, noticing how they move across the sky with mechanical regularity. Rotation, once taken for granted, becomes an object of reverence. The turning of Earth is no longer invisible, it is watched. Calendars are rebuilt with care. Timekeeping becomes sacred. Any deviation in the length of a day, any irregularity in the heavens is recorded with obsessive precision. Humanity has learned through inherited memory that stability is precious and not guaranteed, and the planet continues to teach. Earth's climate never fully returns to its old state. Even thousands of years later, there are regions where weather behaves strangely, places where storms linger longer than expected, where winds blow predominantly in directions that defy ancient models, where ocean currents bring warmth or cold in unfamiliar ways. These anomalies are not random, they are the long tail of disruption. The atmosphere, though stable, operates on a slightly different configuration. The Coriolis effect is unchanged in principle, but its expression has been reshaped by altered temperature gradients and ocean circulation. The planet's heat engine still runs, but its tuning has shifted. Life adapts again and again. Species that evolved after the event carry traits shaped by instability. Plants favor resilience over efficiency. Animals evolve broader tolerances. Ecosystems are less tightly coupled, more modular, less prone to total collapse. The biosphere becomes cautious. Human cultures mirror this caution. Architecture favors flexibility. Settlements avoid over-specialization. Knowledge systems emphasize redundancy, multiple ways to grow food, multiple ways to navigate, multiple ways to survive if one fails. The idea of a single, global civilization never quite returns. Instead, humanity spreads as a network of semi-independent cultures, loosely connected by trade and shared history, but resilient in isolation. Where once efficiency was king, now robustness reigns, and always in the background there is the question, what happened? As scientific understanding deepens, theories emerge. Some suggest an unknown cosmic interaction. Others propose rare gravitational resonances. A few dare to speculate about forces beyond conventional physics, fields, dimensions, or phenomena that interact with angular momentum itself. Most of these ideas remain unproven, but none are dismissed outright because the evidence exists. The planet stopped, then it started again. The implications of that fact are enormous. If Earth's rotation could be interrupted, even briefly, then no system, no matter how massive or stable, is truly immune to disruption. This realization reshapes humanity's relationship with the cosmos. The sky is no longer merely observed, it is monitored. Generations of astronomers watch the movements of nearby objects with increasing sophistication. Asteroids are tracked, gravitational anomalies are studied. Subtle variations in Earth's rotation are measured with extraordinary precision. Humanity becomes a species on watch, not in fear exactly, but in awareness. This awareness eventually extends beyond Earth. As technology slowly advances again, spaceflight returns not as conquest but as caution. Satellites are launched with an understanding of fragility. Orbits are chosen carefully. Instruments are designed to detect not just visible threats, but subtle distortions in spacetime, gravity, and motion. The universe is approached as something vast and powerful, not indifferent, but capable of rare, overwhelming events. Earth's 10 seconds become a reference point, a reminder, and yet as millennia pass, something unexpected happens. The memory softens. New generations born into stability begin to question the severity of ancient warnings. After all, the planet spins, days pass normally, seasons return. The catastrophe is impossibly distant, filtered through myth, record, and stone. Some begin to argue that the event was exaggerated. Others claim it was symbolic, misinterpreted by primitive ancestors. A few insist it never happened at all. This is the cycle of forgetting. It is as old as humanity itself. Even with evidence carved into the planet, belief erodes, comfort returns, the world feels reliable again, and Earth continues to spin. But beneath that reliability, the forces that govern motion remain unchanged. Angular momentum still binds the planet to its path. Gravity still tugs. The moon still steals rotation, millisecond by millisecond. The sun still pulls. The galaxy still moves. Nothing has become safer, only quieter, which raises the most unsettling possibility of all. What if Earth's 10 seconds were not unique? What if they were part of a larger pattern, one too slow, too rare, or too subtle for a single civilization to recognize? The universe operates on timescales that dwarf history. Events separated by millions of years may appear singular to those who experience them, yet form a rhythm on a cosmic scale. If that is true, then Earth's stillness was not a fluke. It was a note in a much longer song. Perhaps other worlds have paused. Perhaps other civilizations have faced similar moments and either adapted or vanished. Perhaps rotation, motion, and balance are not static properties, but variables subject to forces we have yet to understand. Earth's survival, then, is not evidence of safety. It is evidence of resilience, and resilience is not infinite. As humanity looks outward again toward the stars, toward other planets, toward the mechanics of existence itself, the lesson of the stoppage looms large. The universe does not promise continuity. It allows it for a time. Awareness is not a gift, it is a burden. For a species capable of memory, Earth's 10 seconds of stillness become something more than a historical event. They become a quiet pressure, shaping thought long after the details fade. Even when the story is doubted, even when it is mythologized or dismissed, the planet itself continues to whisper the truth. Nothing is guaranteed. As humanity matures again, rebuilding science, culture, and curiosity, this awareness seeps into every discipline. Physics is no longer merely about prediction. It is about limits. Biology is no longer about optimization. It is about tolerance. Philosophy is no longer concerned with meaning alone, but with fragility. The world that spins beneath their feet is understood as a system, vast, interconnected, and conditional. This changes how intelligence evolves. Civilizations that arise after the stoppage do not pursue endless expansion the way their ancestors once did. Growth is measured, redundancy is valued, stability is engineered not as permanence but as adaptability. Cities are built to bend rather than resist. Food systems diversify instead of centralizing. Knowledge is stored in many forms, written, oral, physical, so that no single failure can erase it. This is not fear, it is memory refined into strategy. As observational tools improve, humanity begins to notice something unsettling. Earth is not alone in its vulnerability. Other bodies in the solar system bear scars of rotational change. Mars, with its ancient, chaotic axis shifts. Venus rotating slowly and backwards, a reminder that planetary motion can be radically altered. Rotation, it seems, is not sacred, it is contingent. This realization deepens when humanity looks beyond its own star. Exoplanets are discovered with extreme tilts, erratic spins, and tidal locks so complete that one side bakes while the other freezes. Some worlds tumble, others wobble. A few may once have been stable, only to lose that balance over time. Habitability is not just about distance from a star, it is about motion sustained. In this broader cosmic context, Earth's 10 seconds of stillness take on new meaning. They are no longer just a catastrophe endured, but a data point, an anomaly that demands explanation. Scientists search for patterns. They examine cosmic background fluctuations. They study gravitational waves. They monitor subtle distortions in spacetime itself. The idea that large-scale structures, passing density waves, dark matter filaments, or unknown fields could interact with planetary systems is no longer dismissed. The universe is not empty. It is structured in ways only partially understood, and structure implies interaction. The more humanity learns, the clearer it becomes that Earth exists within layers of motion far larger than itself. The solar system orbits the galaxy. The galaxy moves within a cluster. The clusters drift along filaments of mass that bend spacetime like rivers bend land. Earth is carried within all of this. Its rotation, stable though it feels, is nested inside motions so vast they defy intuition. Which raises a difficult question: was the stoppage local or inherited? Perhaps Earth did not stop because something acted upon it directly. Perhaps the fabric of motion it depended on shifted briefly, altering rotational frames in a way that left the planet momentarily unbalanced. This idea is speculative but not absurd. Physics already accepts that time itself can dilate, that space can curve, that motion is relative, not absolute. If reference frames can shift, then stability may depend on conditions beyond the planet itself. Earth may not have failed, its context may have changed. This possibility unsettles even the most cautious thinkers, because if planetary motion depends on larger-scale coherence, then no world is truly autonomous. Stability is a collective phenomenon emerging from alignment with cosmic structures that may themselves evolve. In such a universe, intelligence faces a new responsibility. To survive long-term, it must not only understand its planet, it must understand the motions that cradle it. Humanity's curiosity expands accordingly. Astronomy becomes existential. Cosmology becomes practical. The study of spacetime is no longer abstract but essential. Early warning systems are imagined, not just for asteroids or solar flares, but for anomalies in gravitational fields, for distortions in the cosmic background, for anything that hints at large-scale shifts. The universe is watched the way weather once was. Patterns are catalogued, anomalies debated, models refined, and yet despite all this vigilance, uncertainty remains, because some events do not announce themselves. Some disruptions arrive without precedent. Earth's 10 seconds were not predicted. They were endured. That fact humbles even the most advanced civilizations that follow. No matter how much is known, the unknown remains larger. This humility shapes ethics. Power is approached cautiously. Technologies capable of influencing planetary systems are treated with reverence and restraint. The idea of manipulating rotation, gravity, or climate is considered taboo, not because it is impossible, but because the cost of error is understood too well. The planet is not a machine to be optimized. It is a balance to be respected. Culturally, the stoppage becomes a lens through which existence is interpreted. Art reflects motion and pause. Music explores rhythm and interruption. Stories revolve around cycles broken and restored. Even language changes. Words for time, stability, and balance acquire deeper meanings. Idioms reference the stillness, not always literally, but as a metaphor for moments when the expected order fails. And quietly in the background of all this growth and reflection, Earth continues to turn. Days pass, years accumulate, the memory of catastrophe dims further, but the lesson remains encoded not just in records and myths, but in behavior. Humanity has learned at a species level that awareness is survival, not awareness of danger alone, but awareness of context. To live on a spinning world is to trust motion. To remember when that motion faltered is to trust it wisely. As millennia unfold, intelligence, human or otherwise, may spread beyond Earth. Other worlds may be settled, other rotations learned. Each new planet will carry its own rhythms, its own vulnerabilities, and Earth will be remembered not just as a cradle, but as a teacher. The world that stopped for 10 seconds taught a thinking species that even the most reliable truths are conditional. That existence is not secured by strength, but by alignment with forces larger than comprehension. Every civilization lives inside an assumption. It may not know it does, it may never name it. But beneath every plan, every structure, every ambition, there is a quiet belief that tomorrow will resemble today closely enough to be navigated. Earth's 10 seconds of stillness shattered that belief once. What follows over deep time is not paranoia, but recalibration. As intelligence matures on a planet that has already proven capable of betraying expectation, the definition of progress changes. Advancement is no longer measured solely by speed, power, or reach. It is measured by coherence, by how well a civilization understands the systems that allow it to exist at all. Motion becomes sacred, not worshipped but studied with a seriousness once reserved for survival itself. Humanity learns that continuity is not guaranteed by intention. It is negotiated continuously with physics, gravity, energy, and chance. And so the question evolves quietly and relentlessly. How long can a thinking species remain aligned with the forces that sustain it? This question does not yield simple answers, because the universe is not static. Even if Earth never stops again, the conditions that allow it to spin as it does are not eternal. The moon continues to drift away, slowing Earth's rotation imperceptibly. The sun grows brighter with age. The galaxy itself changes, its mass distribution shifting over cosmic time. Stability is temporary, even without catastrophe. This understanding reframes the idea of permanence entirely. Civilizations that follow the stoppage begin to see themselves not as masters of a world, but as passengers within a moving system. Their task is not domination, but synchronization, staying in phase with the rhythms that permit life. This philosophy shapes exploration. When humanity ventures beyond Earth again, it does so cautiously. Each new world is studied not just for resources, but for rotational behavior. Axial tilt, orbital resonance, tidal interactions, long-term stability. Planets that appear abundant but unstable are avoided. Worlds that rotate smoothly, predictably are favored not because they are safer, but because their risks are legible. Legibility becomes the currency of survival. Unpredictable systems are not evil, but they are expensive. They demand constant adaptation, constant vigilance. A species that spreads itself too thin across unstable environments risks losing coherence, forgetting lessons learned in one place before they can be applied elsewhere. Earth's stillness taught humanity the cost of forgetting. Over time, this shapes not only science but identity. Humanity begins to define itself not by what it builds, but by what it preserves. Knowledge of planetary dynamics becomes cultural inheritance. Children are taught not just history, but systems, how climate emerges from motion, how gravity shapes time, how rotation underpins life. The idea of natural changes. Nature is no longer seen as benign or hostile. It is seen as conditional, responsive, capable of stability, but indifferent to desire. This perspective does something profound. It removes the illusion of entitlement. No species deserves continuity. No civilization earns permanence. Existence is allowed moment by moment by forces that do not negotiate emotionally. This realization could lead to despair. Instead, it leads to clarity. Because if continuity is borrowed, then meaning lies not in duration, but in alignment, in how well intelligence fits itself into the larger motions of reality. Earth becomes a case study, perhaps the most important one. A planet that nearly lost everything, not through impact or fire, but through stillness. A reminder that chaos does not always arrive violently. Sometimes it arrives as absence, the absence of motion, the absence of balance, the absence of expectation. As millennia pass, philosophers begin to argue that the stoppage was not merely a disaster, but an evolutionary pressure, not biological but cognitive, a filter that favored forms of intelligence capable of humility, patience, and systems thinking. Perhaps worlds that never experience such disruption never develop that depth of awareness. Perhaps stability without interruption breeds complacency. In this view, Earth's 10 seconds were not an anomaly, but a catalyst, a sharpening event. This idea is controversial, uncomfortable, and impossible to prove, but it persists because it resonates with observed outcomes. Humanity that survives becomes less reckless, less certain, more attentive. The species learns to listen to data, to patterns, to silence, and silence becomes important because one of the most haunting aspects of the stoppage was not the violence, it was the quiet afterward. The moment when engines ceased, signals vanished, and the world held its breath. That silence echoes through cultural memory as a warning. Not all threats announce themselves with noise. Some arrive as pauses, as gaps in expected rhythm, as 10 seconds where nothing behaves as it should. This awareness leads to a subtle but profound shift in how intelligence interprets anomalies. Small deviations are not ignored, they are examined. Changes in rotational speed, in magnetic field behavior, in orbital parameters, nothing is dismissed as trivial. Because the stoppage taught a brutal truth, large events can be preceded by almost nothing. No build-up, no countdown, no narrative, just interruption. This challenges humanity's oldest storytelling instinct, the belief that causes must be dramatic to produce dramatic effects. Earth disproved that. It showed that the most devastating events can emerge from precise, silent conditions. That lesson reshapes how risk is understood, not as spectacle but as probability. Over enough time, even rare events become inevitable. This leads to a difficult realization. Survival is not about preventing every catastrophe. It is about remaining adaptable enough to endure the ones that cannot be prevented. Earth's ecosystems did this instinctively. Life reorganized, rebalanced, reemerged. Humanity had to learn to do the same consciously. This is the final threshold of intelligence. The moment when a species stops believing it can eliminate uncertainty and begins designing itself to live with it. At this stage, intelligence becomes something different, not expansionist, not extractive, not defensive, but responsive. Civilizations are no longer judged by how much they control, but by how well they recover. How quickly they can reestablish coherence after disruption, how much diversity of strategy they preserve. Fragility is treated as a flaw, redundancy is treated as wisdom. This ethos spreads beyond humanity. If intelligence encounters other thinking species, the shared language is not technology, but understanding of limits. Worlds that have endured disruption recognize each other. Worlds that have not may struggle to comprehend caution born from experience. Earth becomes a reference point, a world that knows what it means to nearly lose rhythm. And through all of this, time continues. The sun ages, the galaxy shifts, motion persists. Earth's rotation remains steady enough to sustain life, but never again invisible. It is monitored, respected, quietly thanked with every sunrise that arrives on schedule. The 10 seconds are gone, unreachable, sealed in the past. But their meaning is not. They live on in architecture that bends, in science that watches, in cultures that plan not for perfection, but for resilience. They live on in the understanding that existence is a process, not a state, and that motion, whether planetary, biological, or cosmic, is the thread that holds that process together. Motion is not a detail of the universe, it is the universe. From the smallest scales to the largest, nothing truly stands still. Particles vibrate even at absolute zero. Atoms oscillate, planets spin, stars rotate, galaxies wheel through space in vast, slow arcs. Even the fabric of spacetime ripples with the memory of ancient events. Existence expresses itself through movement. And yet within that endless motion there are pauses, moments where rhythm falters, where balance is disturbed, where systems briefly lose coherence before finding it again. Earth's 10 seconds of stillness belong to that category. Not a contradiction of motion, but a reminder that motion is not uniform, that it can fluctuate, stall, accelerate, and reorganize, that the universe does not promise smooth continuity, only persistence. To understand this, humanity eventually learns to look beyond individual events and toward patterns that unfold over immense spans of time. Entropy becomes the guiding concept, not as decay alone, but as transformation. The tendency of energy to spread, of order to dissolve into new configurations. Motion, in this sense, is entropy's companion, the mechanism through which energy redistributes itself across space and time. A spinning planet is not defying entropy, it is participating in it. Rotation allows energy to circulate rather than stagnate. It moves heat, sustains gradients, enables complexity. Life itself is an entropy-driven phenomenon, extracting temporary order from constant flux. When Earth stopped spinning even briefly, entropy surged unchecked. Energy no longer flowed smoothly. It piled up violently, then collapsed. The result was destruction, not because entropy increased, but because it did so too quickly without pathways to dissipate gently. This reframes the event once again. The catastrophe was not caused by stillness alone. It was caused by the sudden absence of controlled motion. In this light, motion appears not as chaos, but as containment. A way of managing inevitability. The universe does not resist entropy, it choreographs it. Stars burn by converting mass into energy, radiating heat outward. Galaxies rotate, preventing collapse into singularity. Planets spin, moderating extremes. Life metabolizes, exchanging energy with its surroundings to delay equilibrium. Everything alive or stable is, in some sense, a dance against sameness. Earth's 10 seconds were a stumble in that dance. The universe did not end. It adjusted, and that adjustment reveals something profound. The universe tolerates imbalance, but only briefly. Systems that fall out of rhythm are either corrected or erased. Earth was corrected at enormous cost. Other worlds may not be so fortunate. This realization leads to a radical rethinking of habitability. A world is not habitable because it sits at the right distance from a star. It is habitable because it maintains motion within tolerable bounds. Because it dissipates energy at rates that allow complexity to persist. Too much motion and systems tear themselves apart. Too little and they collapse into stagnation. Life exists in the narrow band between. Earth's stillness was a step toward stagnation, interrupted just in time. Had it lasted longer, minutes instead of seconds, the outcome would have been far worse. Oceans would have fully redistributed. Atmospheric collapse would have intensified. The biosphere may not have recovered. 10 seconds was catastrophic. 60 seconds might have been terminal. This sensitivity underscores how fine the margins truly are. The universe allows complexity, but it does not protect it. It permits life to arise, but it does not ensure its continuation. Motion provides opportunity, not immunity. As humanity absorbs this truth, it begins to see itself differently. Intelligence is not separate from cosmic processes, it is one of them. Thinking beings are configurations of matter and energy that have learned, temporarily, how to maintain themselves far from equilibrium. They are eddies in the flow of entropy, patterns that persist because motion feeds them. When motion falters, intelligence is tested. Earth passed that test barely, but the universe does not grade generously. This awareness leads to a final, humbling insight. Intelligence may not be rare because it is difficult to originate, but because it is difficult to sustain. Worlds capable of supporting thinking life must remain within delicate bounds of motion for unimaginably long periods. Most do not. They spin too fast, they lock too early, they wobble themselves into chaos. They stagnate under permanent day and night. Earth's long stability was exceptional. Its interruption was a warning. In this context, the 10 seconds of stillness are no longer just a planetary event. They are a glimpse into how fragile complexity is at a cosmic scale. They reveal that the universe is not hostile to life, but neither is it designed for it. Life exists because motion, energy, and time occasionally align just right, and alignment is always temporary. As this understanding matures, a quiet philosophical shift takes place. Meaning is no longer sought in permanence, it is sought in participation. To exist, to think, to remember, to adapt, these become sufficient achievements. Continuity is no longer assumed as a right, but appreciated as a gift renewed with every rotation of the planet. Sunrises become symbols again, not of romance, but of mechanics functioning as they should. Each dawn is evidence that motion persists, that balance holds, that entropy is being managed rather than unleashed. Earth's rotation becomes a kind of cosmic heartbeat, steady, reliable, but never immune. And in that rhythm, intelligence finds its place, not as a ruler of nature, but as a listener, an observer, a responder. The universe moves, sometimes it stumbles, sometimes it corrects. Earth stumbled once. That memory, carried forward through stone, story, and science, becomes part of the universe's self-awareness, expressed through a species that learned to notice. Long after the equations have been written, long after the sediment layers have been catalogued and the myths compared, Earth's 10 seconds remain something no formula can fully contain. Because what stopped was not only the planet, what stopped was certainty. For a thinking species, certainty is the quiet foundation beneath every decision. It is the assumption that the ground will remain where it is, that the sky will behave tomorrow as it did yesterday, that the deep mechanisms of the world are stable enough to ignore. When Earth stopped spinning, that assumption fractured, and although the planet resumed its motion, certainty never fully did. In the centuries and millennia that follow, humanity learns to live with this fracture, not as fear, but as awareness. The pause becomes an internalized presence, shaping how people relate to time, to risk, to ambition. Before the stoppage, humanity imagined the future as an extension of the present. Progress was linear, growth was assumed, problems were obstacles, not existential threats. The world felt large but dependable. Afterward, the future is no longer a straight line. It becomes a branching landscape of possibilities, some thriving, some catastrophic, most uncertain. Planning shifts from prediction to preparation. Instead of asking what will happen, societies ask what they will do if it doesn't. This distinction changes everything. Education emphasizes systems over outcomes. Children are taught how climates form, how feedback loops amplify change, how small disturbances can cascade into planetary consequences. They learn not just facts, but fragility. History is no longer taught as a sequence of events, but as a study of resilience and collapse. The rise and fall of civilizations are examined not for their glory, but for their points of failure, the moments when rigidity overcame adaptability. The pause becomes the ultimate case study. It is the reminder that the most devastating events are not always dramatic in appearance. That catastrophe can arrive as stillness, silence, absence. This awareness reshapes ethics. Decisions are weighed not only for immediate benefit, but for systemic impact. Actions that increase efficiency but reduce resilience are viewed with suspicion. Centralization, once praised, is carefully limited. Diversity in ecosystems, cultures, technologies is recognized as insurance against the unknown. Uniformity becomes dangerous. The pause taught humanity that when everything depends on a single rhythm, a single failure can propagate everywhere at once. Distributed systems survive. Monocultures fail. This lesson applies beyond agriculture or infrastructure. It applies to thought. Intellectual diversity is protected. Competing models are encouraged. Dissent is valued not as opposition but as redundancy. A civilization that thinks in only one way risks missing the anomaly that matters. Earth's stillness was an anomaly no one predicted. That memory lingers. As humanity rebuilds its relationship with the planet, reverence replaces entitlement. Not reverence in a mystical sense, but in a practical one. Earth is no longer assumed to be inert. It is understood as dynamic, responsive, and capable of surprising behavior. Language reflects this shift. People stop saying the planet provides and begin saying the planet allows. They speak less of conquering nature and more of aligning with it. These are not poetic changes, but cognitive ones, subtle adjustments that reshape decision-making across generations. Even ambition evolves. Great projects still exist, but they are designed differently. Instead of monuments meant to last forever, structures are built to be repairable, replaceable, adaptable. Permanence is no longer the highest ideal. Continuity through change is. This is not a loss of confidence, it is a refinement of it. Humanity learns that strength lies not in resisting disruption, but in absorbing it without losing coherence. The pause did not destroy the planet, it tested it, and in doing so, it tested intelligence itself. At the personal level, this awareness manifests quietly. People become more attentive to cycles. Sunrises and sunsets are noticed, not merely observed, whether patterns are discussed with curiosity rather than annoyance. Seasonal changes are anticipated with humility. Time regains texture. Before the pause, time was something to be filled. Afterward, it is something to be respected. Each day's normality is understood as the outcome of countless forces remaining in balance. This does not lead to constant anxiety. Instead, it fosters gratitude, not gratitude for comfort alone, but for function. For the fact that gravity holds, that rotation persists, that air moves in ways that sustain rather than destroy. Earth's motion becomes something like a shared inheritance, unseen, unearned, but deeply consequential. And yet, despite all this awareness, forgetting still creeps in. It always does. As centuries pass without further catastrophe, the pause risks becoming abstract. Younger generations, born into relative stability, begin to treat it as history rather than warning. The planet spins, the skies behave, life feels predictable enough. Complacency, subtle and unintentional, returns. This is not failure, it is human nature, but the pause left behind something that prevents complete forgetting. The planet itself, the scars remain, the altered coastlines, the climate quirks, the geological layer that refuses to blend quietly with those above and below it. Earth carries the memory even when minds drift. Science continues to rediscover it. Every generation that probes deeply enough finds the same evidence, the same abrupt boundary, the same global signature of disruption. The same conclusion that something extraordinary happened and that it was brief. This repetition acts as a corrective. Each rediscovery renews the lesson, even if its emotional weight fades and returns in cycles. Humanity does not remember perfectly, but it remembers often enough. This rhythm of remembering and forgetting becomes part of civilization's heartbeat, and perhaps that is appropriate. Total vigilance is unsustainable. Total ignorance is fatal. Survival lives between them. Earth's pause taught that balance applies not only to planetary systems, but to awareness itself. To live constantly expecting disaster is to paralyze growth. To live assuming safety is to invite collapse. Wisdom lies in oscillation. As the story of the stillness continues to echo through time, it becomes less about fear and more about perspective. The pause is no longer seen as an omen of doom, but as a boundary condition, a demonstration of how far the world can be pushed before consequences become irreversible. 10 seconds mattered. That fact becomes empowering. If 10 seconds can change everything, then small actions can matter too. small stabilizations, small corrections. Small decisions that preserve flexibility instead of eroding it. The pause reveals leverage points in reality, moments where intervention or restraint has outsized impact. This insight informs how intelligence interacts with its environment. Instead of seeking absolute control, it seeks strategic influence. Instead of massive transformations, it favors subtle adjustments that maintain balance. The planet becomes less of a battlefield and more of a conversation. Earth moves, life responds. Intelligence listens, and in listening it learns that the universe does not punish curiosity or ambition, but it does punish ignorance of scale. The pause was a lesson in scale, a reminder that planetary systems operate at levels where human intuition fails. That forces measured in seconds can have consequences measured in millennia. As humanity grows older as a species, this lesson becomes foundational. Children grow up knowing that the ground beneath them is not merely solid but conditional. That the sky above them is not merely blue but organized by motion. That existence is not fragile in the sense of being weak, but fragile in the sense of being precise. The pause did not make Earth hostile, it made Earth honest, and honesty, once absorbed, changes how intelligence chooses to live. If Earth's 10 seconds of stillness taught humanity anything enduring, it was patience. Not the patience of waiting for things to improve, but the patience of seeing beyond a single lifetime. The patience to think in spans of centuries, millennia, even geological epochs. The pause forced intelligence to stretch its sense of time, to acknowledge that the present moment is only a thin slice of a much larger story. As humanity looks toward the far future, this expanded sense of time becomes its most powerful tool. Civilizations rise again, more slowly than before, but with deeper roots. They are shaped not by urgency alone, but by continuity. Decisions are evaluated not just for their immediate impact, but for how they might ripple forward through generations yet unborn. This is not idealism. It is survival refined into foresight. The earth that spins beneath these future societies is stable enough to sustain life, yet visibly marked by its history. The scars of the stillness are no longer wounds, but landmarks, quiet reminders embedded in rock, climate, and collective memory. They anchor long-term thinking, preventing the complete return of short-sighted ambition. Humanity learns to ask questions it once avoided. How long can this ecosystem endure under this strain? What happens if this balance shifts slightly? What assumptions are we making that feel safe only because we have not yet tested them? These questions slow progress, but they also deepen it. Technological advancement continues, but it is no longer detached from planetary understanding. Energy systems are designed to harmonize with climate cycles. Infrastructure adapts to geological realities instead of fighting them. Even art and philosophy reflect a quiet respect for limits. Limits, once seen as obstacles, become guides. As centuries turn into millennia, humanity's relationship with uncertainty matures. The pause is no longer a source of dread, but a reference point, a known extreme against which new risks are measured. Compared to 10 seconds without rotation, many challenges feel manageable. Perspective, once gained, is difficult to lose. This does not mean catastrophe disappears. There are still storms, earthquakes, droughts, and failures, but they are contextualized, understood as part of a dynamic system rather than signs of betrayal. Earth is no longer expected to be gentle. It is expected to be honest. This expectation changes how people respond to hardship. Instead of asking why disaster occurred, societies ask how to adapt without breaking. Recovery becomes as valued as prevention. Flexibility becomes as prized as strength. The pause taught that resilience is not resistance, it is recovery without losing identity. As humanity ages further, it begins to recognize a subtle irony. The event that nearly destroyed global civilization may have been what ultimately allowed it to persist longer than it otherwise would have. Before the stillness, humanity's trajectory pointed toward overconfidence, toward systems optimized for speed and scale but brittle in the face of disruption, toward a belief that technology alone could smooth every uncertainty. The pause dismantled that belief. In its place grew something more sustainable, humility paired with capability. This combination proves powerful. Over deep time, civilizations that inherit this mindset prove more durable. They adapt more gracefully to environmental shifts. They avoid irreversible decisions. They preserve knowledge across generations instead of burning it for short-term gain. They still make mistakes, but they recover. And in a universe where permanence is an illusion, recovery is everything. As humanity looks outward again toward other stars and other worlds, Earth's lesson travels with it. Colonies are founded cautiously. Worlds are chosen not just for abundance, but for stability. Rotational dynamics are studied as carefully as atmospheric composition. Some promising planets are deliberately left untouched, not because they are dangerous, but because they are unpredictable. Humanity learns to walk away from opportunity when the risk threatens coherence. This restraint is new and rare. It may be what allows intelligence to endure. Over millions of years, Earth itself continues to change. Continents drift, mountains rise and erode, ice advances and retreats. The planet remains alive with motion, its rotation steady enough to sustain complexity, yet always evolving. The pause becomes a vanishingly distant moment in time, but it never fully disappears. It remains encoded not just in stone, but in values, in how intelligence relates to the world, in how it measures success, risk, and meaning. Future thinkers look back and realize something profound. Earth did not teach humanity how to prevent catastrophe. It taught humanity how to live in a universe where catastrophe is possible. This is a deeper lesson than safety. It is a lesson about coexistence with uncertainty. In this sense, Earth's 10 seconds of stillness may represent one of the most important evolutionary pressures intelligence can face, not because it selects for physical traits, but because it selects for perspective. A species that cannot think beyond its immediate comfort will not last long in a universe governed by motion and entropy. A species that learns to see itself as part of larger systems may endure far longer than its origins suggest. The pause forced that learning early, and early lessons shape everything that follows. As the sun continues its slow evolution, growing brighter, altering Earth's climate over hundreds of millions of years, humanity is prepared. It plans migrations, adaptations, transitions, not desperately but deliberately, because it has already seen what happens when foundational assumptions fail. The end of Earth's habitability, when it eventually comes, is not a sudden betrayal. It is anticipated, planned for, understood. And when humanity finally leaves Earth behind, whether gradually or all at once, it does so with gratitude rather than regret. The planet was not perfect, it was instructive. It taught intelligence how to think in motion. In the cosmic perspective, Earth's 10 seconds are insignificant, a blink in the lifespan of the universe. But significance is not measured in duration, it is measured in consequence. Those 10 seconds reshaped how a thinking species understood reality. They transformed certainty into awareness, entitlement into humility, ambition into alignment. And perhaps that is the greatest legacy a world can offer its children, not safety, not abundance, But understanding, as the universe continues to expand, as galaxies drift apart, as stars are born and die, motion persists. The great dance continues, indifferent to individual worlds, yet shaped by their collective behavior. Earth played its part, it spun, it paused, it spun again. And in that brief interruption, it taught intelligence how fragile and how precious continuity truly is. There is a concept ancient and easily overlooked that becomes newly relevant in the shadow of Earth's pause. The still point, not stillness as emptiness, not silence as absence, but stillness as contrast, a moment that reveals motion by interrupting it. Earth's 10 seconds were such a moment. They did not erase the world, they framed it. Only by losing motion briefly did intelligence truly understand what motion meant. Before the pause, rotation was background, a given. A constant so reliable it disappeared from thought. The sun rose, the stars wheeled, the seasons cycled. Earth's spin was never felt, never questioned, never thanked. Afterward, rotation became visible not to the senses but to the mind. A world that spins is a world that negotiates extremes. A world that turns is a world that survives gradients. A world in motion is a world that stays alive by refusing to settle. The still point revealed this truth with brutal clarity. In the aftermath, philosophers struggled to name what had been lost and regained. Language faltered because the event did not fit familiar categories. It was not destruction alone, not renewal alone, not punishment or accident in any satisfying sense. It was interruption. An interruption, once experienced, cannot be unseen. Across cultures that rose after the pause, similar ideas emerged independently. Stories of a moment when the world hesitated, when time felt heavier. When the sky seemed too close and the ground unreliable. These stories differed in detail but shared a core intuition. Something essential had almost slipped away, and that intuition shaped meaning. Meaning in a universe governed by motion does not come from stillness sustained. It comes from motion resumed, from the continuation of rhythm after disruption, from the fact that the dance goes on even when it nearly falters. Earth's pause did not give humanity answers. It gave humanity a reference. A point against which all other moments could be measured. In physics, reference frames define reality. Without them, motion is meaningless. Earth's stillness became such a frame, not mathematically but existentially. A 0 point against which life, stability, and continuity could be understood. Before the pause, people asked, "What is the world made of?" After the pause, they asked, "What keeps the world going?" These are very different questions. The first seeks composition. The second seeks process. And process is where the universe hides its truths. Everything that matters is ongoing. Nothing important is static. Even the most stable structures, the mountains, the continents, the stars, are in slow transformation. Stability is not the absence of change, but change constrained within survivable bounds. Earth's rotation is one such constraint. It limits how much heat accumulates. It limits how cold darkness can become. It limits how energy concentrates or disperses. By stopping even briefly, Earth demonstrated what happens when a constraint is removed. Chaos is not always explosive. Sometimes it is simply uncontained. This insight echoes far beyond planetary science. It influences how intelligence understands itself. Thought, too, requires motion. Ideas circulate, perspectives rotate, feedback prevents stagnation. Societies that freeze their thinking, locking themselves into rigid frameworks, begin to fail in ways eerily similar to a planet that stops spinning. The pause becomes metaphor without losing its literal power. Civilizations that remember it tend to favor dialogue over dogma, revision over certainty, adaptability over purity, not because these values are fashionable, but because rigidity has been proven lethal. The The still point teaches that motion within limits is wisdom. As humanity grows older, wiser, quieter, it begins to appreciate something that once seemed trivial. Normal days, a day when nothing remarkable happens, a day when the planet spins as expected, a day when the sky follows its script. These days, once dismissed as dull, become precious. They are understood not as the absence of meaning, but as the presence of functioning systems. Normalcy is no longer boring, it is miraculous. This does not diminish curiosity or ambition, it refines them. Exploration continues, not driven by conquest, but by understanding. Discovery is valued not for novelty alone, but for how it integrates into the larger picture of stability. Even risk is reinterpreted. Risk is no longer something to eliminate, it is something to distribute, to ensure that no single failure cascades unchecked, to design systems, biological, cultural, technological, that fail gracefully rather than catastrophically. Earth's pause was a failure that did not remain contained. That lesson echoes forever. As intelligence spreads beyond Earth, it carries the still point with it, not as fear but as calibration. New worlds are approached with respect for their rhythms. Colonies are designed to listen before they act. Rotational dynamics are treated with the seriousness once reserved for atmosphere and gravity. Motion is monitored. Change is expected. Surprise is planned for. And yet, for all this wisdom, one truth remains unavoidable. No amount of awareness can guarantee safety. The universe does not bend to preparation. It does not reward caution with immunity. It simply allows complexity to persist where conditions permit. Earth's pause did not happen because humanity was careless. It happened because the universe is capable of rare, extreme deviations. This realization humbles even the most enlightened civilizations. It reminds them that knowledge reduces risk but never eliminates it, that survival is probabilistic, not assured, and still intelligence chooses to continue. This choice to exist despite uncertainty is perhaps the most profound consequence of Earth's stillness. Faced with the evidence that the ground beneath reality can falter, humanity does not withdraw from existence. It does not retreat into paralysis. It adapts. It builds meaning not on promises, but on participation. To live is to accept motion. To think is to accept uncertainty. To remember the pause is to accept fragility without surrendering to it. The still point becomes a quiet companion to every decision, not loud, not dramatic, simply present, a reminder that nothing essential is automatic. As the universe ages, as stars burn out and galaxies drift beyond one another's reach, Earth's 10 seconds will become unimaginably distant. Long after human voices fall silent, long after intelligence changes form or disappears entirely, the planet's rocks will still carry the mark. A thin line, a disrupted layer, a moment when the world hesitated. That line will not explain itself, but it will testify. It will say, here something almost ended, and also here something continued. That duality is the heart of the story. Not destruction or survival alone, but the narrow space between them. The still point was not the end of motion. It was the moment motion revealed its value. And as Earth continues to spin day after day, era after era, it does so with a history that cannot be erased. A history that teaches quietly and persistently that existence is not defined by how fast it moves, but by how it responds when movement is almost lost. This is where our journey pauses, not because the story is finished, but because it has reached the place where all such stories converge. At the edge between motion and stillness, between certainty and awareness, between what is given and what must be earned every day the planet turns, there is no final moment when Earth's story resolves. There is only continuation. After all the analysis, all the memory, all the reflection, the planet does what it has always done, what it must do. It turns quietly, relentlessly, without ceremony. The sun rises, the horizon shifts, time moves forward. And yet nothing about that motion is ordinary anymore, because once you have imagined a world without it, once you have felt, even in thought, the weight of 10 seconds without rotation, you can never again see a normal day as trivial. Earth turning is no longer background noise, it is the story. Every sunrise becomes evidence that balance still holds. Every predictable season becomes proof that the negotiation between gravity, motion, and energy continues to succeed. Every calm ocean current and steady wind pattern becomes a quiet triumph of physics over chaos. The world does not promise permanence, it demonstrates effort. Earth's 10 seconds of stillness were not a prophecy of doom, they were a revelation of dependency. A reminder that life, intelligence, and continuity are not guaranteed by existence alone, but by alignment, by countless forces remaining in delicate cooperation. The planet did not fail, it faltered, and in faltering it taught. It taught that motion is not speed but rhythm, that stability is not rigidity but responsiveness, that survival is not strength alone but awareness sustained over time. For humanity, this lesson reshaped everything, not overnight, not perfectly, but deeply. A species that once believed it stood apart from nature learned instead that it stood within it, carried by motions far older and larger than itself. A species that once equated progress with control learned to equate it with understanding. A species that once chased permanence learned to value continuity through change. Earth's pause did not make humanity small. It made humanity honest, honest about limits, honest about fragility, honest about responsibility. And in that honesty, intelligence found something rare in the universe: durability, not immortality, not invincibility, but the ability to persist with eyes open. The universe continues to move outward, indifferent to individual worlds. Stars burn and fade. Galaxies drift apart. Time stretches beyond comprehension. Somewhere other planets spin smoothly. Somewhere others wobble, lock, or shatter. Earth remains one of the fortunate ones, not because it avoided disruption, but because it survived one. The pause became part of its identity, a scar, yes, but also a signature, a mark that says, this world nearly lost its rhythm and found it again. And perhaps that is what all enduring systems share: not perfection, but recovery. Not unbroken motion, but the capacity to resume motion after interruption. Earth turns. It turns for the forests that adapted, for the oceans that reorganized, for the creatures that survived, evolved, and learned, for the intelligence that learned to listen instead of assume. It turns for the quiet understanding that existence is not owed to anyone, but can be honored by how it is lived. The 10 seconds are gone. They will never return. They exist now only in rock, memory, and imagination. But their meaning continues to turn with the planet, a reminder that every ordinary day is supported by extraordinary balance. That every moment of normalcy is, in truth, a collaboration between forces that do not have to cooperate but do. And that awareness, once gained, never truly fades, so the world turns, and as it does, it invites a simple response: not fear, not awe alone, but attention. Attention to motion, attention to balance. Attention to the fragile miracle of a planet that keeps time by spinning. If you've stayed with this journey to the end, thank you for sharing this moment of stillness and motion with us. If you enjoyed this exploration, please subscribe to the channel for more deep, calm, and thought-provoking journeys like this one. Leave a comment below what part of this story stayed with you the most, and let us know where you're watching from. No matter where you are on this spinning world, you're part of the same motion. Until next time. The earth keeps turning.